Hi, grade 8. This is a math video for lesson 8-9, which is talking about something called the solving of systems of equations. Now, what does that mean? It basically means, and you'll find this out shortly, that sometimes on a graph, you'll want to graph two separate lines, and you'll want to figure out exactly where those two separate lines meet or don't meet. If you look at page 414 and 415, 414 and 415, you will see some example problems of the solving of systems of equations. Example 1 is showing you somebody who has graphed the two lines, and they have found out that those two lines do meet. Do you notice where? It's at location -1, +1. And so -1, +1 is the solution for example 1. Then go to example 2, which is a word problem talking about video game rentals. And in that one, the two lines meet at location 832. That's the solution of that problem. And if you look carefully, you'll notice that because it meets there at 832, they're able to translate that into 8 videos at $32 for those 8 videos. Look at example 3. Do you see in example 3 how sometimes when you plot two lines on a graph, they don't meet at all, they're parallel. And I gave you a hint about that last week. Remember when we talked about the fact that when lines have exactly the same slope, they tend to be parallel to each other? Look at the two line names for example number 3. Y equals 2x plus 4, that's a slope of 2. And y equals 2x minus 1, that's also a slope of 2. And because they have the same slopes, they are parallel lines. Now finally, example 4 shows you a situation where two lines are sitting right on top of each other. They are exactly the same line. And so the book describes that as a situation called infinitely many solutions. Let's turn the page to number 416. They have one other thing that they want you to learn how to do, and that's solving these kinds of equations by substitution, which can sometimes happen. In other words, sometimes you're able to solve a system of equations without even graphing them. And that's what example 5 is trying to show you. Okay, let's start with some example problems. We're going to start first with two equations, y equals x minus 1, and our other equation, y equals 2x minus 2. We're going to graph them, and we're going to see where they meet. Okay, the first thing I notice is neither one of these is in slope-intercept form. Slope-intercept form would be y equals mx plus b. There's no plus sign here. So I'm going to change subtraction to adding a -1, and I'm going to put a 1 out in front of the x because x is 1x. Then I'm going to graph it. My first dot's going to go at -1, and my slope is a +1, so I go up 1 and over 1. Hey, here's my line right here. My line goes right along here. Okay, that's my first line. Second line, I'm going to put a dot at -2. Why? Because it says so right here. Subtracting 2 is the same thing as adding a -2. And then I'm going to go up 2 and over 1. Up 2 and, whoa, look at this. This line goes right here. And so, what's the solution for this system of equations? The solution is +1, 0. +1, 0 is the spot where those two lines meet. Let's try a second situation. It's cold in here, so things aren't erasing very well. Y equals 1/3 x minus 5, and y equals 1/3 x plus 2. Are bells going off in your head right away? What do you notice about the slopes? They're identical, aren't they? Let's see what happens when we graph them. I'm going to put a dot at -5 for this first one. And then, because subtracting 5 is really adding a -5, then I'm going to go up 1 and over 3 to put my second dot. And there's my line. Second one, I'm going to put a dot at 2. And I'm going to go up 1 and over 3 to graph the second line. Where do they meet? They don't meet because the lines are parallel. Therefore, the answer to this problem is no solution. If the lines are parallel, the answer is no solution. Let's try another one. What if I wrote y equals 3/4 x plus 6? And the second one is 4y minus 3x equals 24. What do you notice right off the bat? I can graph this one. But I can't graph this one until I turn it into slope-intercept form. So let's graph this one first. I'm going to put a dot at 6 on the y-axis, and I'm going to go up 3 and over 4 and put my second dot. And then I got to work on this and try to figure out a way to change it into slope-intercept form. Well, let's first realize that this 3x needs to be on the other side of the equation. So I am going to add 3x to both sides of the equation to move it to that other side. And when I do, I get 4y equaling 24 plus 3x. Now, I got to get rid of that 4 away from the y. So I'm going to divide every single term by 4. And when I do that, I get a y value equaling 6 plus 3/4 x. Hey, let's flip that around so that the 3/4 x is first. Remember that? And when we do that, I'm noticing something. Look at this. Those are the exact same equations. Y equals 3/4 x plus 6, y equals 3/4 x plus 6. So that means that this line is actually two lines, the first solution and the second solution. So what do we say for an answer? We say infinitely many solutions. Why? Because every single dot on this line is a spot where the two lines are sitting upon. Every single dot. So infinitely many solutions is the answer to that one, just like it is in example 4 at the bottom. Let's try a word problem. First, I'm going to grab a rag gun that has some rubbing alcohol on it and see if we can get this to erase a little bit better than the eraser's doing. There we go. Well, it's not doing great, but it's doing better than the eraser would have done, I think. Okay, word problem. Imagine that you have the chance to go into a club for buying CDs for music. And in one club, we'll call it Club A, they charge a yearly fee of $25. And then after that, the CDs after that are $5 per CD. There's another CD club, we'll call that Club B, and they don't have an annual fee, so their annual fee is 0, and they charge $7.50 for every one CD. How many CDs would you need to buy in a year for the clubs to cost the same? And in which club would it be a better deal for a customer buying 20 CDs in a year? Those are the two questions we're going to try to face here. So when are the clubs going to cost the same, and 20 CDs. If I buy 20 CDs, which club should I go with? Those are the issues we want to solve here. Well, first of all, let's come up with some equations for this. For this one right here, this is a fixed cost, and this is the cost that varies. So in my mind, I'm thinking to myself, the unknown in all of this is how many CDs I'm buying. So I'm going to write y equals 5 times x plus 25 for club A. Now why did I do that? Why did I do that? Y equals 5 times x plus 25. The y is the total cost of using club A. I don't know how many CDs I'm buying, but I'm going to call that idea x. The amount of CDs I buy times 5 plus the annual fee is going to be the total cost of y. Now what about club B? Club B is going to be a situation where the amount I buy CDs for is $7.50, and there is no annual fee, so I write $7.50 times x plus 0. And if I figure this out, that's my total cost of y. Let's graph these. Let's graph these. Now, this is going to be a little bit interesting because we've got pretty high y values here. We've got 25 there. How do I handle that? And I've also got this weird number of 7.5 for a slope. So I got to think about that. So I'm going to go by 5s. And let's see if that works. It might work, it might not work. I'm going to go by 5s and see what happens here. I might have to start. So, I put a dot at 25. My slope is 5 and my run is 1. Right? Slope is 5 over 1. 5 over 1, so I rise 5 and run 1. Rise 5, run 1. That would be like right here. That's a kind of strange line, isn't it? I'm not sure this is going to work for me because it's not real precise, is it? The next one, I've got 0 as my y-intercept, and I've got 750 as my rise over a run of 1. So I've got to go up to here and run 1 right here. Boy, where in the world are those going to meet? They will meet. They're not parallel, that's for sure. This is a steeper slope than this. This line is steeper than this line, but I'm not going to be able to see it, am I? I'm not going to be able to see it. I think I got to start over and think differently about how I'm going to do this. Well, let's imagine that the y is way down here instead. Okay, this is my x-axis is way down here. And this is my x-axis. And let's, instead of going by 5s, let's try going by, how about 2s? So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, so we're going to put a dot down here at 0, and we're going to rise 7.5. That's going to take us way up here and go over, let's just call this 1 and 2 and 3. We're going to go by 1s, 2s, and 3s. And let's see what happens. 7.5 would be about here, and 1 would be right there. We go another 7.5, that would take us to 15 and over to here. Then another 7.5 up would be 22.5 and 1 over would be here. Okay, so that's this line down here. Where's my 25 line? I'm going to go up 5 and over 1. And then up 5, This is from 25 to 30, that's up 5. Then from 2, 4, 5, my next stop would be right there. Boy, they're still not going to meet very soon, are they? How am I going to get those to meet? Goodness, I don't know. Let's try doing this. Let's change it back to 5s. 10s, 15, 20, 25s, 30s, 35s, 40s. I know they're going to meet, I just don't know where they're going to meet. So now I'm going by 5s, and I'm anywhere from 5 all the way up to 70 here. My first dot's at 25, and I got to go up, 5 and over 1. So that'd be here, 5 and over 1, here, 5 over 1, 5 over 1, 5 over 1, 5 over 1. This might actually do it. I don't know. 5 over 1, 5 over 1, 5 over 1. Now what about this one? We're going to start down here. We're going to go up 750 and then over 1. 750 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 over 1. 750. Hey, guess what? They finally meet right here at this spot. By this time, the video's how long? Oh, video's at 17 minutes. We finally figured it out. Now let's extend this number out. 7, 8, 9, 10. Is this 10 right here? Yeah, that's 10. So above 10, now this is going to be 10 CDs down here, right? And over here, this is money, right? So at what point do the programs cost the same? They cost the same where they meet. And so that's when we buy 10 CDs. That's when the cost is the same. If I buy 20 CDs, which one's cheaper? Well, do you notice how this line's going to go this way and this line's going to go this way? So if we're way out here buying 20 CDs, this is going to be the cheaper cost compared to this one. And that's the one that starts at 25. So A is going to be the cheaper one at $25. Hey, 8th graders, we still haven't talked about how to simplify these problems solving by substitution. So let's get to that. I'm going to pour rubbing alcohol here to clean off the board. It's 58 degrees in the room here, and at 58 degrees, nothing wants to erase very well. This is the only way to get it to work. Notice on that last one, in order to do it, I had to think about how I was going to graph it 3 different times before it finally worked. That's okay. Sometimes that's the way math is. Okay, now what in the world do we mean by solving problems by substitution? Let's throw a problem on the board here. What if I wrote on the board y equals x plus 1, and then I wrote that x equals 3, and somebody said, solve this not by graphing, but solve it by substitution. Well, the first thing I notice is that they've already told me half of the answer. They have told me that the x value is 3. The only thing I need to figure out is the y value. It says so right here, the x is 3. So how do I figure out the y value? Well, let's just take this x value and put it right here. If I put it right here, what does y have to be? Y has to be 4. So in this particular case, if these are the 2 equations, the x has to be 3 and the y has to be 4 because I have to put that 3 here to make that 4. Let's try a different one. How about y equals x plus 2 and y equals 0. This time, they've told me right off the bat what the value of y is. They're telling me y is 0. So if I put that 0 right here where the y is, bring the 0 right here, x plus 2 equals 0. What does x have to be? X has to be negative 2. Let's try another one that's a little bit more complicated. Y equals 2x plus 7 and y equals negative 5. Using the concept of substitution, I already know that the y value is negative 5, because they tell us that right here. And now I'm going to take that negative 5, I'm going to put it right here, and I'm going to solve for the x. Let's subtract 7 from both sides, and that would give me negative 12 equaling 2x, which means that the x has to be negative 6, because negative 6 times 2 is negative 12. So in this case, if y equals negative 5, then the solution of the two equations is negative 6, negative 5, because they have to meet at that point. Okay, let's try one more. What if I've got x plus y equals 6, and I've also got x equals negative 4? Well, the first thing, they've already told me the x value is negative 4, so I'm putting that there. Secondly, let's take this letter x and turn it into negative 4. Negative 4 plus what number would get me to 6? Well, isn't it 10? Negative 4 plus 10 is positive 6. Yep, so there's my solution. Okay, really long video, 8th graders. Sorry about that.